Welcome back to math class via YouTube. It is Sunday, 12 o'clock p.m. I know what you're thinking. You're thinking, Mr. McMahon, why are you just now doing this? And I'll tell you. It's because I've already recorded this. But apparently my microphone was not on. So the whole thing has no audio. So let's get back into it, shall we, gang? Today we're talking about solving quadratics via factoring, by factoring, because graphing takes too long. Round 2, because round 1 was made on Thursday. And here we are. Awesome. So, let's get down to it. Let's get down to business, Mulan style. We talked about in class, well, you will talk about tomorrow, Monday, which is great, about graphing. Let me make sure you guys can see all this junk. Yes, you can. You can see everything. We're talking about graphing, right? That's what we did on Monday. And the thing is just graph the quadratic, figure out where it crosses the x-axis, and then that's your solution. Those are your zeros. That's your roots. Amazing. And now, here's the thing. As we know, I had to first find the vertex from plugging into negative b over 2a. Then I had to plug in that 3 all the way into the original problem to find my y value, which was negative 1. Once I found that, then I had to create a table, a nice little table here, so that I can find other points in this graph. So then eventually I could figure out where it crosses, here and here. And then I'm like, great, awesome, that's my final answer. Now, that problem alone took Mr. McMahon, myself, a math guy, 4 whole minutes to do, which is way too long. Way too long. And now, we're going to learn a way that's a little bit quicker. Now, that does not mean that this is not important, right? To be able to look at a graph and go, oh, I see the zeros, they exist right there, is vitally important. And being able to graph quadratics is very important, especially for later on when we do some applications with these problems. But regardless, I will tell you a trick. It's called factoring. And you guys have seen it, or at least heard of it, a little bit before. So this is the exact same problem as before. So if we recall, hold on, let me see real quick. The final answer to this was 2, 4, right? So I will say, because I know this for a fact, 2, 4. We've already solved this one. I know what the answer is. But I'm going to show you a way that can do this, that can really figure this out. So first off, I'm going to do it really quickly, and I'm going to explain what I did. So I look at this. And I go ahead and I think about what goes into 8. And I'm like, okay, so 2 and 4, 1 and 8. But I need to make it so it adds up to negative 6. So negative 2, negative 4. When multiplied, become positive 8. But when added together, become negative 6. So if I just do this, and then x minus 4. Wow, this is looking pretty good. I basically unfoiled it. I'm going to create this little makeshift table right here so that I can solve these individually. Now, if I solve these individually, I'm left with, I would add the 4 over here, so I'm left with plus 4. I would add the 2 over to here, I'm left with x equals 2. That easy. And if you look, I just found the answer a lot quicker than, graphing it. And you're thinking maybe to yourself, like, what did he do? What are the steps for there? So let's just take a rein back real fast. I just wanted to prove to you that this works this way. But I will really start to break down what just happened. Like, how did that even happen? That was so fast. What the heck is going on? And I promise you it's not too bad. So first off, I started off with looking at this 8, right? That's what I put the line underneath it. And I thought to myself, I want to unfoil this. Factoring is basically unfoiling something, like taking something back out before it was distributed. And if you know, foiling is first, outer, inner, last. Hopefully you guys understand that when you have, like, the whole 2 parentheses, and you're like here, 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 that kind of junk. That's foiling, right? So I have that in mind. So I really start to think about how can I undo this. And I look at the component, or I look at the number 8, and I think, okay, what times what equals 8? So first off, you can say 1 and 8, then 2 and 4. And then that's about all we got with 8, right? And now I start to think, okay, so I know that 2 and 4 is going to have to probably be it, or 1 or 8 will be. But which combination of these two, rather 1 and 8 or 2 and 4, will add up to be negative 6? So obviously none of them, but if I made both of these negative, technically speaking, negative 2 times negative 4 is positive 8. And then negative 2 plus negative 4 is negative 6. So that kind of works out. So I will show you what I mean by that. X minus 4. So I did that earlier. No big deal. Let's just rein it back and let's do a little bit of a foiling just to see if it worked. So first I do x times x, which is x squared, minus 2x. And then this over here, minus 4x. And then negative 2x times negative 4 makes positive 8. And if I were to combine these, I get this. X squared minus 6x plus 8. And if you notice, it's the exact same as the original. So this foiling technique, this factoring technique, works fine. It works perfectly. And what's super nice is that where the zeros exist, like we're trying to find zeros of an x value, right? Where they exist is whenever y is 0, right? So, like for instance, right here, where these zeros all exist, the y value on the y-axis is actually 0. Like this is y equals 0, right? So with that in mind, I can kind of set this, I can set this whole thing equal to 0 and then solve them by themselves to find the right answer. So x minus 2 equals 0, x minus 4 equals 0. So then when I add this guy over here, this becomes x equals 4, and then x equals 2 over here, which we figured out before. This is the correct answer, so it checks out. Yeah, so that's the basics of factoring. Now we're going to, of course, do more. There's a little bit more to it than just that. It wouldn't be math without a little bit more intense stuff. So we're going to do one like this. So we're going to keep that in mind. Again, we're trying to find zeros, so where it crosses the x-axis. And now, the last one we were able to just kind of jump right into it. This one, obviously, there's something going on. We need to factor something out, actually, before we even get into the core of factoring. And in that sense, I'm going to try to see if I can take anything away. I see a 2, I see a 16, I see a 40. I think to myself, ooh, yo, I can probably take out a 2 from all of these, right? Technically, if I divide all these by 2, that can work. So I'm going to take a 2 out, leaving me with x squared minus 8x minus, what is that, 20? That looks pretty good to me. Okay. Now, I'm going to keep this in mind. I'm going to look at negative 20, and I think what goes into negative 20? Negative 20. That means that one of these numbers being multiplied has to multiply to become negative 20, right? One of them is going to have to be negative. So I know that, well, negative 20 and 1, 20 and negative 1, that's probably not going to help me because, again, I'm looking at negative 8, right? I want these numbers to add up to negative 8. So what else goes into 20? You could say negative 5 and 4, and 5 and negative 4. Okay, so that's not it. Negative 5 plus 4 is negative 1. 5 plus negative 4 is just 1, so that's not good. But then you start looking at, you go 10 and negative 2, negative 10 and 2. So again, these don't work. These add up to becoming negative 19, not negative 8. This doesn't work. This doesn't work. This doesn't work. 10 minus 2, 8. Not quite negative 8, but we're getting there. Negative 10 plus 2 is negative 8. So this is our magic number right there. So actually, that's what we're going to... can you... Oh my gosh, if I did all that without... perfect. So now I'm going to basically use these... There's a big thing though. This 2 right here still remains there. Does it really matter? Not technically for the answer, but I say we just keep it simple and leave it there. So 2 times x minus 10 times x plus 2, good to go. Now I'm going to make that little table thing that I was talking about earlier, just like this. Technically, this side gets 1 too, because if the 2 was an x, you would still be able to solve here. But in this case, when I set 2 equal to 0, that doesn't do anything for me, so this doesn't matter. X minus 10 equals 0. That makes x equal 10. X plus 2 equals 0. X equals negative 2. So boom, perfect. My x values are at x is negative 2 and 10. That means if you're on the x-axis, this parabola, which is opening up, will cross at, technically I guess it's this way, positive 10 and negative 2 is where they're crossing at the x-axis. Wonderful. And you could totally figure it out, and you can check it by plugging it in. I don't want to do that. You can do it yourself if you want to. You can pause this video and try it, but I think we're good to go. So good. First rule basically is to make sure that we are factoring out stuff if you can. That's a key point there. if you can. So if we have a problem like this real fast, let's see how much time we have. If we're at the good, we're at 10 minutes, good. I wanted this to be about 15. We might push into 17-ish, but I think it'll be okay. Anyways, I'm going to look at, again, obviously there's nothing in front of the x squared, right? So we're good. If it's x squared is 1, we're good. We're good, unlike the other one was 2. I'll show you a method on how to do the other stuff too. Anyways, I'm going to look at negative 48. Negative 48. What goes into negative 48 that can add up to 2? So I start thinking, I don't want to write out a whole bunch of things, but I mean, we can if we want to. So like 2 and 24, that's obviously not going to work, right? No combination of negative 2 or negative 24 is going to become 2. So let's start thinking, what else goes into 48? Well, 48 divided by 8 is 6. And 8 and 6, the combination of those two might work. So let's think 8 and 6. And now I want positive 2, so the 6 just has to be the negative, so that when I multiply these two, I become negative 48. That is it. That's it. So we end up having x plus 8, because it's a positive 8, and then x minus 6. Boom. Just like that. And if I were to FOIL this thing all out, it would become this problem again. But I don't want to do that. We've already done that before, so we're all good. Why did I just do that? I said I'm not doing it. I'm going to make that real quick table. X plus 8 equals 0. X minus 6 equals 0. So x equals 6. X equals negative 8. And I know what you're thinking. Do I have to make that table every time? Absolutely not. No. I just find math to work better when I see it visually. Like I see this table and I know what's happening. That's good. If you just look at x plus 8, x minus 6, and you say the zeros are negative 8 and positive 6, you're good. So those are my solutions. X equals 8, or negative 8, and x equals 6. Those are the zeros. Those are the roots. Good. And that's it for this one. We're going to do one big problem that we're really going to focus on mainly in class. But here's the thing. What happens if you can't take a number out? You've got a 5 out in the front. So the biggest issue that we come across as math people right now, what do we got here? How's this looking? Perfect. Is we want to find the easiest way of doing stuff, right? We don't want to have a lot of mistakes to be made in math. So with that, there's this guy, Barry something, I don't know, but we call it the Barry method, the good old Barry method. And I linked another video to this. Nancy Pye did one, and she does this X version, and I don't like that, but if you want to take a shot at it, you can. And what the Barry method is instead of having to like divide everything by 5 and working with it, we're not doing that. We're going to wait till the very end to take away 5 from the whole problem. So this is going to be really weird. And when I mean weird, I mean weird. This is just some squirrely math that just somehow works. 5x, 5x, boom, right there. So that's my start. Obviously, this is wrong. Because if I were to FOIL that already, I'd get 25x squared, and that's not correct. It's because we're going to wait to the end to pull out the 5 as much as we can. So just hold your horses here. And I know it's weird, but it is what it is. But what we're going to do instead, because we have 5 inside of here, we need to amplify everything. So we're going to take 5 times negative 48. And that would be negative 48, 240, negative 240, right? Negative 240, yeah. All right, so we end up having negative 240 is our A times C, which is a big one. Now, instead of looking at the negative 48 for what adds up to 22, we're going to look at negative 240. And you think, oh gosh, Mr. McMahon, I don't want to have to do all that. That seems like a lot of work. And it is. It is a lot of work, which is why, but I promise you that trial and error would be a lot longer than doing it this way. So I'm going to take 240 divided by, let's just say 5. 48 and 5. That's obviously not going to be 22 because one of these has to be negative. Negative 5. So like 48 minus 5 is obviously 43. So that's not what we want. So 240 divided by, let's do 8. 30. Okay, that was actually super lucky. That's actually hilarious. 8 and 30. If I make the 8 negative plus 30 is positive 22. So that was nice. 8 and 30. So with this in mind, one of these has to become negative because it is negative 240. So I'm going to make the 8 negative because negative 8 plus 30 is positive 22, which is what we want. So I've got negative 8 and positive 30 in here. And now here's where the Berry method really shines. I said before that we're going to take stuff out in the later, right? Well, later is now. So I'm going to look, and can I remove a 5 smoothly from this? 8 divided by 5 is not nice. That's not pretty. I don't like working with fractions if I don't have to, so why should you? Now I look over here, and I see 5x plus 30. 5 and 30 can have a 5 taken away from them. So I'm going to rewrite this one. This other guy stays the same. This 5x minus 8. But this guy is going to change to x plus, what is it? 6, yeah. Oh my gosh. I did the math wrong all in my head. I was actually looking over here at the final answer. Good, okay. Because if I remove a 5 here, if I divide this by 5, this becomes 6. And now if you look, I've got 5x minus 8, x plus 6. And that's actually my final little solution there. So we are going to hit the 17 mark, but no big deal. If I were to find the zeros of this, I do the same thing. I just put them equal to 0. So x plus 6 equals 0 becomes x equals negative 6. That's one of the solutions. And then 5x minus 8 equals 0. I would add the 8 over, so this becomes 5x equals 8. So then x equals 8 over 5, because I would divide the 5 over to the other side. So these are my two solutions. At x equals 8 over 5, and at x equals negative 6. Now, this looks weird, but I'm going to real quickly prove that this works. So 5x times x is 5x squared. 5x times 6 equals plus 30x. Negative 8 times x equals negative 8x. Negative 8 times 6 makes it negative 48. And already this is looking real sharp. 5x squared, negative 30 minus 8x becomes positive 22x minus 48. Boom, 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 boom. Good. So this technically is not my solution, but I'm just letting you know that that is proven to work. Berry method works. It gives us negative 6 and 8 over 5, which is the correct zeros. Boom. Great. Done. Awesome. Come ready to play tomorrow. We're going to really work on that Berry method in class, and I'm proud of all of you, and I'm super sorry that this is out. Wait, no. It's not even out yet. This isn't even due yet. I'm going to be posting this tomorrow. It's fine. You guys are fine. I just had to stay up later, which is ridiculous, but oh well. It's worth it. I'll see you guys.